Jai Hind, dear students. I'm Dr. Preeti Mittal, and today we are going to revise some of the phenomenon related to scattering of light. These phenomena include Tyndall effect and the color of the sky. Why it appears to be blue. So, what is scattering of light? Scattering of light occurs because of the presence of particles of dust, water vapors, and other suspended particles in the atmosphere. When light rays falls on these particles, the light rays scatter in all directions. Means the light rays spread in all directions. So when light rays falls on any of the particles, the light rays are going to spread in all directions, and this phenomenon is known as scattering of light. Now, because of scattering of light only, we see the color of the sky, that is blue. We see the Tyndall effect. Now, let's study what is Tyndall effect. Tyndall effect is illumination of the pathway of light whenever light rays passes through a colloidal solution. Air, when it contains dust particles or the water droplets are there in the air, that also behaves like a colloidal solution. It's a heterogeneous mixture. Actually, air is a heterogeneous mixture of dust particles, water vapors, and different suspended particles in the air. So, when light passes through these particles, the pathway of the light is visible to us. And this visible pathway of light is only known as Tyndall effect. Some examples of Tyndall effect is if you are sleeping for some quite late, especially on Sundays, then you must have observed sometimes if a light beam is entering into the window, then you can see the dust particles are visible in that pathway of light. So that is an example of Tyndall effect that we see in general life. Apart from that, canopy of forest means whenever you see the scene of a forest in a movie or on television, then you see that you can see the visible light rays of sun in the forest, because the forest area has a lot of water vapors, a lot of mist is there in the forest area. So that makes the pathway of the light visible to us, and that only is an example of Tyndall effect. Apart from that, why is the sky appears to be blue in color? The color of the sky appears to be blue. That is also because of scattering of light. The light of that the if the size of the particles in the atmosphere is small, then the scattering will be maximum for blue colors, because that is a smaller wavelength. Blue has smaller wavelength, and red color of light, red part of the light, has longer wavelength. Now, when the particles in the atmosphere are small, then the light rays that are going to be scattered the most is the blue color. And so when we talk about the atmosphere, the blue color is having the shortest wavelength. The particles that are there in the atmosphere, that are also having the smaller size, and so the blue color scatters the most, and so the sky appears to be blue in color. Okay, but if you are an astronaut and you go into the space and you try to look into the space around you, you will find that everything around you will be completely dark. It will be completely black. In space, there will be no scattering of light because there is no atmosphere, no particles are there. So, if you go into space and there is no particles in the space, and so the sky will appear to be completely dark to an astronaut, because in absence of atmosphere, there couldn't be scattering, and if scattering is not there, then we do not see the light around us. Fine. So that is the reason of the color of the sky being blue. The scattering only is the reason behind the color of the deep sea also. Okay. So that's all about this chapter. We have completed a revision of the complete chapter. In the next video, we are just going to revise the numericals from the chapter. That's all for today. Good day, everyone.